Okay, this hopefully is the very last video I have to do for the final exam review for semester 1 for my Algebra 2 class. Now, we're going to go through and do this. For each of the given rational functions, identify the zeros. Okay? The zeros will be the zeros of the numerator. Vertical asymptotes will be the zeros of the denominator because you can't divide by 0. And the horizontal asymptote, if there is one, that will depend upon the ratio of the degrees. If the degree in the numerator is larger, or the degree in the denominator is larger. So we'll check that out. Okay, so first of all, for number 70, the zeros. Well, if you look at the numerator, x squared plus 9. If you take a number and square it, it'll be positive. Take a positive number, add 9, it's going to be positive or greater than 0. So there are no zeros or no x-intercepts. Just going to say none. Okay, vertical asymptotes. All right, for this, vertical asymptotes, you have to look at the zeros of the denominator. X squared minus 2x minus 15. You could either set it equal to 0 and use quadratic formula, or you could try and factor it, and I prefer factoring if I can. X and x, two numbers that multiply to be negative 15, add to be negative 2, that'd be negative 5 and positive 3. If you set that equal to 0, the two values that make this equal to 0 will be x equals 5 and x equals negative 3. So the vertical asymptotes are actually at x equals 5 and x equals negative 3. Okay, the last part, horizontal asymptote. Okay, there are 3 different rules for this. If the degree of the numerator and degree of the denominator match, then you use the leading coefficients. The leading coefficient for the numerator and denominator are both 1. So the horizontal asymptote is a y equals 1 over 1. Well, so the horizontal asymptote is just at y equals 1. So no zeros, vertical asymptotes at x equals 5 and x equals negative 3, and horizontal asymptote at y equals 1. That's for 70. 71. Let's check this one out. Zeros. Well, if we set x to the third minus 8 equal to 0, and solve it, add 8 to both sides, x to the third equals 2, or x to the third equals 8. Third row to both sides, x equals 2. So the 0 would be at the point 2, comma 0, because the 0 by definition is where y equals 0, or the function equals 0. Vertical asymptotes. Now, this one's a little strange because it's not written in normal form, but it's wherever 6 minus x squared equals 0. So 6 minus x squared equals 0. Well, I'm going to add x squared to both sides. So 6 equals x squared. Take the square root. Plus or minus the square root of x. So x is at plus or minus the square root of x. So the vertical asymptotes are at x equals square root of 6 and negative square root of 6. Even though they're irrational, they're still real. So there are vertical asymptotes. Now, horizontal asymptotes. Okay. Now, the degree in the numerator is 3. The degree in the denominator is 2. Since the degree in the numerator is larger, as x gets larger and larger, so will the function g of x. All right, so if it continues to increase, that means there's no number it gets close to and continually gets closer to, so there is no horizontal asymptote. So I'm going to put none for horizontal asymptote because the degree of the numerator is larger than the degree of the denominator. So as x gets large, the function will increase without bound. All right, the last one, number 72. I'm going to zoom out for this. not that far. Okay. Check this out, folks. An object is thrown from a height of 200 feet above the ground at a velocity of 40 feet per second, which is modeled by the height equation, h equals negative 32t squared plus 40t plus 200. What is a reasonable solution to when the object hits the ground? Okay. Now, here's the key to this problem. I'm not going to do any math. We're just going to reason. What's a reasonable solution? Okay, when you start a clock, the time is never negative. So t equals negative 1.95 seconds is not going to be the answer because the time is not going to be negative. All right. Over here, they give you two options at two different times. Well, you're still not going to have a negative solution, so this is also not a solution. And for D, we have the same problem. We will not have a negative time. Not in the real world, when time always starts at 0. So, by process of elimination, the reasonable solution is C. The time equals 3.2 seconds. Now, if you wanted to check that to make sure, you could go h equals negative 32 times 3.2 squared plus 40 times 3.2 plus 200. You could go through and actually calculate that out to make sure it equals 0. And have fun with that. Okay, well, have a good night. All right, if you actually made it through any or all or even just this video, come up to me right before the final and say, hey, I saw what was on the video and the secret word is purple. Okay? Thanks. Bye. You can see what happens then.